So in this video we are going to see exercise 8.4 from chapter number 8, and we are specifically looking at problem number 5, which says prove the following identities where the angles involved are acute angles for which the expressions are defined. So we have already seen the first 8 problems. Okay, now we have to see the 9th problem and the 10th problem. Okay, so let's zoom in here so that we get idea what is our problem number 9. So let's read the problem. So problem number 9 says cosec A minus sin A into sec A minus cos A is equal to 1 upon tan A plus cot of A. Okay, so these problems are of type where you are given the equations, you have an expression in the left hand side, you have expression in the right hand side. We typically start with the expression given on the left hand side, and we typically convert them into sine and cos, which are our basic foundational trigonometric ratios, and then we keep on simplifying the expression and try to get the expression which is given in the RHS. That's the general strategy. Now one hint is given here in the question which says simplify LHS and RHS separately. So first we'll simplify this, we'll get some expression. Then we'll simplify RHS, we'll get some expression, and both these expression will be equal to each other. And thus we will say this term is equal to this term. Okay. So let's begin with LHS. So LHS is equal to, let's note down the given question, cosec A minus sin A into, okay, into sec A minus cos of A. Okay, so again first let's write them into 1 minus sin A, convert everything into sine and cos, that is our strategy, and this is going to be 1 upon cos A minus cos of A. Okay, yes, so that is equal to 1 minus sine square A the whole upon sine A, this is our first bracket, this is our first bracket, multiplied by 1 minus cos square A the whole upon cos of A, this is our second bracket. Now we have our, let me take it here, so we have our trigonometric identity sine square A plus cos square A is equal to 1. Okay, so using this trigonometric identity, is equal to 1. Now using this trigonometric identity, we can say 1 minus sine square A is equal to cos square A. So I'm going to just substitute that. So this is going to be cos square A the whole upon sine A. This is my first bracket as it is. And in second bracket again 1 minus cos square A. Okay, 1 minus cos square A is going to be sine square A. So I'm going to write here sine square A the whole upon cos of A. And now we can clearly see this is sine square A, this is sine A. So they will reduce each other. Cos square A and cos A, they will also reduce each other. So what we are going to get is sine A upon, sine A into cos of A, or rather I'll just reverse it. It's okay, it's actually going to be cos A into sine of A. So this is my LHS so far, it cannot be simplified further. So let's keep the LHS at this point only, and now let's go ahead with the RHS. So I'm going to zoom into the RHS here. Okay, so let's take RHS this side. So I'm going to just write it here, RHS is equal to 1 upon, this is tan A plus cot of A. Okay, so once again the strategy is to convert them into sine and cos. So this is going to be 1 the whole upon, this is sine A upon cos of A plus cos of A the whole upon sine of A. Okay, now let's continue, that is equal to 1 upon, yes, so sine A into sine A, that is sine square A, plus cos A into cos A, that will be cos square A. So I'm going to do that, simplify this fractions, plus cos square A, and this whole upon will be cos A into sine of A, cos A into sine of A. Now once again we have this identity, okay, sine square A plus cos square A is equal to 1. So I'm going to substitute that here. Okay, so that, let's go down, so that is going to be 1 the whole upon, this is also 1 divided by cos A into sine A. Okay, and now this cos A into sine A will come into the numerator. Okay, basically what is happening, I am multiplying this by cos A sin A, and I am also multiplying the numerator by cos A into sin A. Okay, so this cos A sin A, this cos A sin A, they cancel each other out, and what remains is this numerator. Okay, so this is also going to be equal to cos A into sin of A. So thus we have simplified RHS. Now let me use a highlighter. This is a simplification of RHS, cos A into sin A, and this is a simplification of LHS, cos A into sin A. So both of them have got simplified to the same term, cos A sin A, and thus we can say LHS is equal to RHS. So this is how we prove this problem number 9. Now let's erase this. Okay, let's zoom in and let's reveal this problem number 10. Okay, let's in fact remove this then. Okay, fine. Let me remove this. How do I? Okay, this is fine. Okay. Oh my god, where is it? Fine, I think it's gone. Okay, let's come to problem number 10. Let's read the problem. Now, 1 plus tan square A, the whole divided by 1 plus cot square A. This is one whole expression, that is equal to 1 minus tan A, the whole divided by 1 minus cot A, the whole square, and that is equal to tan square A. So we have three trigonometric expressions here. This is expression 1, this is expression 2, and this is expression 3. And all these three are equal to each other. And let's see how we can prove that. So once again, we start with LHS, that is equal to 1 plus tan square A, the whole divided by 1 plus cot square A. And our strategy is always the same, convert everything into sine and cos. So we are going to do that. So this is going to be 1 plus sine square A upon cos square A, because that is what is tan A, the whole divided by 1 plus cos square A upon sine square A, okay, because that is cos of A. Now that is equal to, let's solve the numerator, cos square A plus sine square A, the whole divided by cos square A, and then denominator is sine square A plus cos square A, the whole divided by sine square A. Okay, now clearly this is a trigonometry identity 1, this is a trigonometry identity 1. So we are going to use that, and that is going to be equal to 1 upon cos square A, the whole divided by 1 upon sine square A. And now once again we will multiply the denominator by sine square A, and we will multiply the numerator as well by sine square A. Okay, and this sine square A and this sine square A will cancel each other out. Okay, and thus we will get this as equal to sine square A, the whole divided by cos square A, which is nothing but tan square A, which is our right hand side expression. Okay, so this is proved. So this expression, let me use a highlighter here. So we have proved that this expression is equal to tan square A. So that is done. Now let's focus on this expression. So let's come to this side. Okay, so I'm going to just mark an arrow here. Okay, so 1 minus tan A, the whole divided by 1 minus cot A, and there is this whole square. Okay, so once again we are going to convert everything into sine and cos, and let's see what happens. So this is going to be 1 minus sine A upon cos A, the whole divided by 1 minus cos A upon sine A. Okay, and this whole square, don't forget the whole square. Okay, now that is equal to cos A minus sine A, the whole divided by cos of a. That's our numerator, and denominator is equal to sin a minus cos a, the whole upon the whole upon sin of a. So this whole upon sin of a, and then this bracket whole square. Okay. Now once again we are going to rearrange. So that is going to be equal to yes, this is going to be cos a minus sin a, the whole upon cos of a. This is our numerator. Okay, multiplied by, this is going to be sin a upon sin a minus cos a, sin a minus cos a. Okay, and then this whole square. Now if you note, this is cos a minus sin a, this is sin a minus cos a. So they are actually same, but we have to just take a minus 1 outside. So let's do that. So that is okay. So this is equal to, I'm going to write here minus 1. Okay, and then this term, let me use the highlighter, this term I'm converting into this term. So that is going to be equal to sin a minus cos a, just by taking minus 1 outside, and into I have sin a here, and the denominator here we have cos of a, and here the numerator, and here the numerator we have again sin a minus cos of a. Okay, and don't forget the whole square, there is this whole square. Now as you can clearly see, sin a minus cos a, sin a minus cos a, they will cancel each other out. So what remains inside the bracket is minus 1 into sin a, the whole upon cos of a, and then this whole square. Now minus 1 square is equal to 1, so that's going to be 1, and sin a upon cos a is tan a, so that's going to be tan square a, which is exactly equal to tan square a, which is also equal to our right hand side. Yes, thus we have successfully shown that both these terms, okay, let's try to zoom in and let me use a different highlighter. We showed that this is also equal to tan square a, and we showed that this term orange is also equal to tan square a. So thus this term is equal to this term, and both of these are collectively equal to tan square a, and that is how you solve this problem.